Hello, everyone, and welcome to the afternoon session of this RoboGen workshop. I'm Rigang Yang. I'm going to be the host for this afternoon session. Our first talk comes from Dr. Wu. Dr. Wu got his PhDs from Beijing University of Post and Telecommunications. He is currently a senior expert at the Tongyi Lab, Alibaba. His research focuses on large model pretraining, multimodal understanding, and generation. Today, he's going to present Chenfei image, large image generation foundation model. Let's welcome Dr. Wu.
Hey, hello. Hi everyone. I'm Chenfei Wu from Queen team at Alibaba Group. Today, I'm excited to introduce Queen Image, a fundamental image generation model. You might be wondering, what does Queen Image have to do with embodied AI? The answer lies in my subtitle. I say fundamental visual generation models are fundamental embodied simulators. So before I dive into the main question, let me first walk you through the Queen Image roadmap. So Queen Image is a young but fast-moving open source project. It officially kicked off on May 6. Just 3 months later, on August 4, we open sourced Queen Image, a large-scale visual foundation model with strong text rendering capabilities, including artistic text rendering, small-scale text rendering, bilingual text rendering, and complex layout rendering. Shortly after, on August 18, we released Queen Image Edit, which enables single image editing. Then, on September 22, we launched an enhanced version, Queen Image Edit 2509, which extends support to multi-image editing. So since its release, Queen Image has garnered significant attention from the community. First, developers have been actively building on top of it. We now have over 400 adapters on Hugging Face, more than 60 fine-tuned models, and over 200 live demos. Second, artists are increasingly adopting Queen Image tools for creative workflows. To date, users have created more than 14,000 LoRa models based on Queen Image. Notably, among the top 3 most likely open source Queen models, Queen Image and Queen Image Edit occupy 2 spots. Moreover, a vibrant ecosystem has emerged across multiple platforms, including Hugging Face, ModelScope, LibLibAI, ComfyUI, and WaveSpeed, demonstrating strong cross-platform adoption and community engagement. So let's start with the image containing a robotic arm and a red ball. You can then directly provide action instructions to Queen Image, such as pick up the red ball, and Queen Image will generate a new image visualizing the result of that action. You can continue with follow-up commands like raise your arm so that it is parallel to the desk. Now, here's the interesting part. You can even imagine and add new objects on the fly. For example, place an empty glass on the table. This is fundamentally different from traditional component-based simulators, where every object and interaction must be predefined. With Queen Image, you can freely imagine any object you need and generate it instantly at low cost. Finally, you can issue a command like put the red ball into the glass. The Queen Image will render the outcome accordingly. Importantly, all these examples were generated directly in Queen Chat with no fine-tuning or spatial setup, demonstrating Queen Image's strong zero-shot visual reasoning and generation capabilities. Then we give it natural language instructions, no code, no physics engine setup, just plain English. So first instruction, scroll down and hug the knees tightly. So Queen Image generates a realistic image of the robot crouching into a compact squat. Next, balance on the tip of one foot with the other leg lifted upward, performing a ballet pose. So the model renders the robot gracefully, balancing on one toe. And finally, balancing in a tilt handstand supported by one hand on the ground, while the other hand extends outward to maintain stability. Queen Image visualizes the robot executing a dynamic, acrobatic handstand, complete with body tilt and counterbalancing arm extension. What's remarkable here is that we are not simulating physics or joints. We are simulating embodiment through vision and language alone. Queen Image interprets spatial intent, understands body posture, and generates physically plausible outcomes, all from text prompts. So now let's look at another fascinating example, this time featuring multi-agent embodied interaction, a humanoid robot and a robot dog. We started with the input image, a robot walking alongside a robot dog, connected by a leash like a human walking their pet. So first instruction, the robotic dog stands up. So quick image generates a new scene where the dog lifts its torso and front legs, transitioning from a crouched position to standing upright, while still attached to the leash. Next, the robot on the left crawls. The model renders the humanoid robot dropping to all fours, crawling forward on hands and knees, maintaining spatial coherence with the dog and the environment. What makes this powerful is that quick image does not just generate isolated poses. It understands agent-to-agent relationships, physical constraints, and environmental context. It simulates not only what each agent does, but how they interact, even when those interactions are novel or untrained. This isn't a traditional robotics simulation. There is no predefined motion capture, just language-guided visual imagination. Again, this reinforces our core idea. Fundamental visual generation models are fundamental embodied simulators. With quick image, you can simulate complex multi-agent behaviors simply by describing them in natural language. Okay, now let's zoom out and look at the big picture. How quick image fits into the future of embodied AI. So on the left, we have virtual world perceived by virtual robot, and on the right, we have physical world perceived by real embodied robot. At the center sits the embodied agent powered by multimodal large language models responsible for language-based planning. What should I do? And beneath it, the embodied simulator powered by visual generation models like quick image responsible for visual planning. That is, what will happen if I do it? Here's how it works. The embodied agent receives high-level goals via language, such as pick up the cup from the table. It then delegates to the embodied simulator, quick image, to visually simulate the outcome. What does the scene look like after I pick up the cup? This simulated visual feedback informs the agent's decision-making, enabling safer, faster, and more intuitive planning before any action is taken in the real world. In other words, language tells the agent what to do, and vision tells it what will happen if I do. This is not just about generating images, it's about building a predictive, perception-aware action planning loop that bridges imagination and reality. And here's a key insight. Visual generation models like pre-image are not just creative tools. They are fundamental simulators for embodied intelligence. They allow us to think before acting in pixels, in scenes, in 3D spaces, without needing expensive physical trials or pre-built physics engines. That's why we say fundamental visual generation models are fundamental embodied simulators. Yeah. So it's worth noting that when training quick image, we did not specifically construct or include robotic data. Instead, our focus was on building a high-quality, well-balanced dataset that reflects the real world. We collected and carefully created billions of image-text pairs, prioritizing diversity and representativeness over raw scale. As shown in this chart, our dataset is organized into 4 main domains: nature, design, people, and synthetic data. The nature category, making up 55% of the data, forms the foundation. It includes everything from landscapes and animals to food, objects, and indoor scenes. Essentially, all non-human, non-design content. This broad category teaches the model to generate realistic, diverse, and everyday visuals. At 27%, design category covers structured visuals like posters, UIs, slides, and various art formats like paintings, cartoons, or digital arts. This trains the model to handle complex layouts, text rendering, and artistic styles accurately. The people category at 13% focuses on portraits, sports, and human activities. This ensures the model sparsely to avoid introducing artifacts or biases that could harm the model's reliability. In short, by balancing these four domains, we build a data set that empowers Queen Image to handle a wide range of real-world generation tasks naturally, reliably, and without needing nice data sets like robotics. So beyond careful data balancing, we also implemented an extremely rigorous data filtering process. Our pipeline consists of 7 sequential stages from S1 to S7, each designed to address a specific dimension of quality, removing noise, ensuring image text element, preserving semantic diversity, and maintaining distributional balance. Starting from raw pre-training data, we progressively refine the dataset, filtering out low quality or misaligned pairs, enhancing resolution, and preparing multi-scale training samples. At every step, we are careful not to sacrifice semantic richness or distort the underlying data distribution. In short, this multi-stage figuring ensures that only the cleanest, most meaningful, and well-aligned image text pairs make it into training, laying a solid foundation for Queen Image's strong generation capabilities. Now, let me show you how we filter the data. I use 4 metrics as an example. First, Luma score measures brightness distribution. We keep images with scores between 0.15 and 0.89, filtering out overlay dark or brown out photos like this raining street scene or overexposed stretches. Second, saturation score evaluates color richness. We accept the images with scores up to 0.9. That means vibrant things like Christmas tree are kept, while oversaturated or monotonous textures like fabric close-up get filtered out. Third, RGB entropy measures visual complexity and detail. High entropy means rich content. We set a lower bound of 5.5, so detailed things like this sculpture or decorated tree paths, while simple flat images like this tile are removed. Finally, canny sharpness. Canny sharpness detects edge clarity. We kept it at 0.25 to avoid blurry or noisy images. A sharp photo of people running kept, but soft focus textures like denim or leather filtered out. These aren't arbitrary thresholds. They are collaborated to preserve high quality, visually meaningful content while systematically removing noise, artifacts, or low information images. Actually, we have quite a lot filtering operators, ensuring every image that trains Queen Image is clean, clear, and semantically rich. So this is an overview of Queen Image architecture. It adopts a standard double-stream MMDIT architecture. The input representations are provided by a frozen Queen 2.5 VL and VAE encoder. For editing tasks like modifying an existing image based on a prompt, we introduce 2 distinct control signals. The first is semantic control. This comes from Queen 2.5 VL. It tells the model what to change, the meaning, the concept, the content. For example, add a red car or change the sky to sunset. Second is the appearance control. This is fed through the VAE encoder. It preserves the visual style, lighting, texture, and structure of the original image, ensuring edits feel natural and consistent with the source. These 2 controls work together. Semantic control guides content, appearance control anchors consistency. That's how we achieve precise context-aware edits. Now, let me walk through the core design philosophy behind Queen Image training. Rather than a linear sequence of stages, we follow 5 guiding principles from easy to hard strategy. Together, they shape how we scale complexity across resolution, content, data quality, distribution, and supervision. First, from low to high resolution, we begin with simpler, low-resolution images where global structure matters more than fine details. As training progresses, we scale up to higher resolutions, like 640 multiplied 640 and beyond. So the model gradually learns to render intricate textures, sharp edges, and realistic lightning. Second, for non-text to text-rich images, images without text are easier to the model. So we start there, landscapes, objects, portraits, and only later introduces scenes with text like posters or UIs. This staged exposure helps the model to learn to generate not just any image, but one with legible, well-placed, and contextually appropriate text. Third, from massive but noisy data to created high-quality data. Early on, we leverage large-scale diverse data to build broad visual understanding, but as training advances, we shift toward cleaner, more refined subsets, ensuring the model does not just see more, but sees better. Fourth, from unbalanced to balanced distributions. So, and actively rebalance category distributions over time. So the model develops uniform competence across domains like natural design and human activities, avoiding bias toward dominant classes. So fifth is from real world data to carefully synthesize data. Finally, we started with purely real human created images. Only later and very selectively do we incorporate synthetic data generated via controlled text rendering pipelines. Crucially, we exclude AI-generated images to prevent artifacts, hallucinations, or style or collapse. These 5 principles are the sequential steps. They are parallel strategies, all aided by one idea: skillful complexity. Let the model master the easy before confronting the hard. And that's how Qwen achieves both rapidness and precision across resolution, semantics, and style. So Qwen demonstrates strong general capabilities in both image generation and editing. I would also like to take this opportunity to further showcase some specific capabilities of Qwen Image Edit. So we started with this simple input like the Qwen mascot, and use our editing pipeline to transform it into a ready-to-print assets like T-shirts and bags. So this slide demonstrates Qwen Image's strength in material-aware editing. Starting from a single flat icon, the model can realistically render it in diverse materials, capturing their unique textures, reflectance, and lightning. This enables designers to instantly explore high-fidelity product variations all from a single prompt. So photo coloring is another powerful editing capability. Given a black and white photo like this historic image of a man with early computing hardware, so Qwen Image does not just guess colors, it intelligently infers realistic tones based on content, skin, suit fabric, metal panels, even wood textures. The result is a vibrant, lifelike colorization that feels authentic, not artificial. You can also use Qwen Image to instantly transform one photo into multiple professional or causal avatars, from ID photos to LinkedIn portraits to social media snaps. Just describe the look, change the background, outfit, pose, even add text. The model preserves your identity while adapting style and context, all with a single prompt. So post-editing goes beyond changing what's in this image. It lets you to control how the person moves, almost like directing an embodied agent to perform actions. From a single standing photo, you can generate expressive gestures like performing a heart with hands or holding a welcome sign, all while preserving identity, clothing, and lighting with remarkable consistency. This isn't just image editing. I would call it embodied simulator. So meme creation is also interesting. Turning any image into a viral ready meme in one prompt. We can change the expressions, add gestures, and insert stylized text like 我支持Tongyi Lab, which means we support Qwen. So while keeping the vibe consistent, while it's whether it's a real person and an enemy character, or even a dog. So it's not just editing, it's cultural remixing, so powered by visual understanding. So given a single input photo, we can simulate physical interaction, placing a marker in hand, adjusting pose, even rendering realistic text on a glass panel behind him, all while preserving lighting, perspective, and spatial consistency. It's not just image editing, it's simulating how a person would act and appear in a real scene. That's the power of grounding generation in embodied understanding. So quick image isn't just generating images, it's simulating human presence in context. Given a single skeleton, just like key points, you can generate photorealistic people, a woman in handful holding an umbrella in a Suzhou garden, or a man on a subway platform with a train rushing by. It doesn't just copy poses, it understands how bodies occupy space, how clothing drapes and moves, and how the environment responds to human presence. This is a simulation grounded in physics, culture, and scene dynamics. So I say visual generation models are super embodied simulators. So Qimage isn't just simulating one embodied agent. It's capable of simulating multiple agents interacting in a shared scene. We started with two separate portraits, a woman and a man, and generated a cohesive, emotionally reasonable, even spatial depth, all perfectly alien. This goes far beyond photo editing. It's simulating co-presence, social cues, and shared context, subtle human things that make interaction feel real. And here is the kicker. Simulating real humans is actually harder than simulating robots. Why? Because humans carry emotion, cultural nuance, unpredictable expression, and complex social signals, all of which must be preserved and harmonized. So here is where Queen Image proves it's not just editing, it's simulating embodied interaction with the world. We take two inputs, a luxury bag and a model, and simulate her wearing it, how it hangs on her shoulder, how the fabric drapes, and how light reflects off the leather. Or we combine a supercar and a woman and simulate her standing beside it, leaning casually, framed by the environment, not pasted in, but placed as if she belongs there. This is more than compositioning. It's simulating spatial awareness, physical contact, and contextual harmony, exactly what an embodied agent is to act naturally in a scene. Image does not just generate images, it simulates how humans inhabit and interact with their surroundings, making it a true visual embodied engine. So in this example, control and rendering happen together. Okay, in one seamless step, we give it three inputs: a girl with a leg behind her, a target outfit that is a black dress, and a reference pose, the key points. And out comes a photorealistic image, the girl seated naturally, wearing the dress as if it were hers, with correct force, lightening, and posture, all alien to the pose skeleton. Low separate steps, low post processing, no mismatch between control and appearance. So this is joint control and rendering. So what would normally take multiple steps, like selecting an outfit, choosing accessories, and placing them on a model, adjusting lighting and pose, Queen Image does it all in one visual thought, or we say visual planning. So visual planning is fast. Input three elements: an necklace, handbag, and a model in a scene. Output is just a photorealistic image where she's wearing both, standing naturally with perfect lighting and composition. No manual composition, no layer by layer editing. This isn't just efficiency, it's intelligent synthetic. The first one is fundamental visual generation models are not just image creators. So they are fundamental embodied simulators. They don't merely render pixels. They simulate how agents occupy space, interact with objects, and respond to environments, grounding vision in physical and social reality. The second, in the broader landscape of embodied AI, I believe multimodal large language models act as embodied agents, deciding what to do, while visual generation models like Queen Image serves as embodied simulators, predicting what will happen if I do it. So together, they form a powerful feedback loop from perception, decision, simulation, and action. So third, Queen Image already demonstrates strong generation across diverse editing tasks, and we are building even further. Further, we will introduce Queen World, our next generation generative model, designed to simulate the real world with greater accuracy, fidelity, and understanding. And finally, here are our links. Yeah. Okay, thank you.
Thank you for the great talk. So we have time for questions.
Yifei, could you unmute? We cannot hear you anymore. We want to participate the Q&A as well. Okay.
Woman to pick up the bag and the necklace. So I think you are talking about like a video, a sequential images, right? I think this is our like future direction. We are working on this. I think video is an extension to videos because a single frame of video is just an image, right? So as I just talked about the word, Queen word is our next most important directions. We want to build a world with sequential frames to reveal the real world embodied AI interactions. Yeah, that's all. Thank you.